Good morning, Ariela.
Morning, teacher.
Okay, let's continue for the chemical reactions. Yesterday, we learned until this one, isomerisms. There are many isomerisms, more than 5 for dibromophenol. Now for the chemical reactions. It is the mechanism for benzene is always electrophilic substitution. And last time I told that the condition has to be extreme or harsh condition. In this one, the harsh condition is using anhydrous iron 3 bromide catalyst, or it is called as Friedel-Crafts catalyst. So in this one, in some textbook, it is written as Friedel-Crafts catalyst. This is for benzene. And for the benzene, this one, there is a mechanism. We know that bromine, this is the formation of the electrophile. We know bromine can become electrophile, can become a nucleophile, depending upon the catalyst and depending upon the compound or molecule that reacts with the bromine. In this one, iron 3 bromide, we know iron 3 bromide has a lack of electron in the structure of iron. That makes the iron is readily to accept electron from bromide. So in this one, we know that bromine is electronegative element. So one bromine is should be giving up its electron, and the other bromine is taking the electron. So the electron is being taken. That makes this Br become negative. The negativity of this Br makes this Br rich in electrons. The electrons can be donated or make a coordinate bonding with this FeBr3. As the result, this bromine will become the electrophile, and this bromide is become the nucleophile. This nucleophile will not react with the benzene. This is only catalyst. And then what is happening in this one? Why is there ring and then a curly arrow to the Br positive? We know that in benzene has overlap pi bonding system, has a pi bonding system. This pi bonding system, it means there is a rich in electron, high electron density. This is comes from the concept of the alkene. Alkene has a high electron density. This high electron density can give its electron to the Br positive or goes to the electrophile. But this once the Br gets the electron from the benzene, this benzene will not undergo addition reaction. It will undergo substitution. What is being substituted? The hydrogen. So at the same time, there is a partial positive. What does it mean partial positive? This one, initially there is a double bond and there is a partial double bond here. So the partial double bond is breaking. That makes this goes to the Br, bonding with Br and bonding with hydrogen. And what does it mean by the arrow that goes inside? It means the hydrogen is giving up the electron, or the electron of the hydrogen. Here there is a dot and cross for the carbon with the hydrogen. So the electron is being taken by the benzene. Why is it being taken? Because by default, benzene has a overlap pi bonding system, has a pi bonding system in the structure. So this benzene will not lose its basic property. It will take the electron from the hydrogen because bromine is stronger electrophile than the hydrogen. So makes the hydrogen gone, move out. And then it's move out, the hydrogen is located over here. We know that the FeBr4 negative has excess of electron because there is a dative covalent bond in the structure that makes the electron of the Br here can be donated to the H plus because this one can react, then the product will be HBr and FeBr3. While the Br, this one is attached to the benzene ring. So this one is bromobenzene. This one, it is called as halogenation reaction of benzene. Okay. So there is a halogenation reaction of benzene. Next, this one that I told previously is the same as halogenation. And this one, there is a bromination. In halogen, there are chlorine, bromine, iodine, fluorine, and astatine. But fluorine will not react. Why? Why does it not react? Because it has very strong attraction. And then, how about acetine? Acetine is less likely to react because it is not easy to react. It is solid at room temperature and pressure. Very solid. It has high boiling point. It means it has the strongest van der Waals forces in halogen groups. So this one, in the bromination, the reaction between bromine and iron 3 bromide. Besides using iron 3 bromide, we can use aluminum bromide. So Friedel-Crafts catalyst, it is not only made up of iron, but it can be made up of aluminum. So only these two. and then there is a partial. In the beginning, in the before slide, it is partial positive. And this one is also called as the partial positive. Okay, so what does it mean? It means this one is the rotation is the same here and this one. They are the same because the reaction is the same. Okay, next, chlorination. Chlorination is another type of halogenation. Chlorination is also using iron chloride. So remember, in order to make a reaction between benzene and bromine, in order to make bromobenzene, we have to use aluminum bromide or iron 3 bromide. The catalyst should support the reactions that we want to react with benzene. So not recommended to make reaction between chlorine and aluminum bromide. What will happen if there is a reaction between aluminum bromide okay for the aluminum bromide for the aluminum bromide the the reaction must be bromine. Next, so the mechanism is the same, is electrophilic substitution. So in order to answer question in A level regarding the mechanism, you have to draw. Which one has to be drawn? This is the mechanism that you have to draw that I blocked. This one is the reaction mechanism. Okay. After chlorination, then there is a nitration. Nitration, in order to attach the nitrate at benzene, we have to use nitric acid in presence of concentrated sulfuric acid with temperature less than 55 degrees Celsius. So this one will become nitrobenzene. This one is the reaction of the catalyst or the formation of the nitrates. So we need the presence of sulfuric acid in order to make this one. So benzene reacts with nitric acid without sulfuric acid and temperature less than 55, nothing will happen. It only happens when there is a presence of concentrated sulfuric acid and temperature less than 55. Okay, next. Next, how's the mechanism of the nitrobenzene? It is the same concept, electrophilic substitution. The question is, how exactly the mechanism is? This one NO2 has a positive. It has lack of electron. And this benzene rich in electron. It has high electron density. The high electron density can be donated and make the active covalent bond with the NO2, especially with the N, not with the O. So when you are drawing this one, the arrow, it has to point the N, not pointing the O. And then creates the partial positive. The electron of the hydrogen is being taken by the benzene. Once it is taken, the hydrogen will move away. Move away, it will become H plus. And this one become nitrobenzene. This is the mechanism. Again, if you have to draw the mechanism, this is the mechanism. Next. So there are many reactions of benzene. So you can start making your mind map. Benzene reacts with HNO3. Benzene reacts with CH3. And then benzene reacts with chlorine. What are the catalysts, the conditions, and also the product? Benzene reacts with halogenoalkene. This benzene reacts with halogenoalkene will become methylbenzene. Methylbenzene, or it is called in other chemistry book as toluene. This is called as another name is called as toluene. Toluene. Last time I ever asked Nathan V about TNT. Nathan V, do you still remember what TNT is?
TNT, tetranitrotellulose, something, an explosive.
Try nitro
Trifo nitro
toluene.
toluene.
This is
Yes.
trinitrotoluene. Trinitrotoluene is effective and very explosive.
Yes.
So how to make the trinitrotoluene? We must have the basic toluene. This is called as the toluene. After we have the basic toluene, then we have to substitute the hydrogen in the benzene with nitro, trinitro. So that is becoming TNT. TNT is in the form, can be in the form of liquid, can be in the form of solid. Okay. And then the mechanism for the catalyst or the formation of the electrophile is the same as the um, halogenation of benzene. Of course, there is a active covalent bonding. And then after the active covalent bonding, the alkophilic substitution mechanism is the same. So there is the partial positive charge.
Mm-hmm.
Okay.
Yes.
Next, isolation. Isolation is the reaction between benzene and acyl chloride. This one, it is called as acyl chloride. Okay, this is an acyl chloride. Acyl chloride, the mechanism is the same as the nitration of benzene, alkylation of benzene, halogenation of benzene. It is the same. What can be observed in here? There is the reactive covalent bond in all the stages of the reaction. Okay, so this is the acyl ion. This one is the catalyst that has undergone reactive covalent bond. This acyl ion reacts with the benzene. There is a partial positive charge. So the acyl react with the benzene and then attach. So this is called as the acylation. Okay. This acylation, we can consider it as a ketone. Why? Because ketone has the structure of R C double bond O R 2 1. So this is R1 and this one is the R2. It has similar structure. Okay. Next. Now, how about if substitution in substituted arenes? What does it mean? Yesterday, I already give an example like this one. Sorry, wait. Like the example is not acylation, nitration, bromination. In this one, in this structure. In this structure, there must be one of them must be the first that reacts with the benzene. And then the next one will become the substituent. That is called as the substituent of the benzene in the substituted of benzene. Okay. And then let's go back to this one. Okay. Let's go back to this one. Substitution in substituted benzene. What is the meaning of this table? There must be a meaning for this table. Why there is a X group and Y group of this one. The X and Y, it means the X is the elements or the functional group that is already written over here. Okay, it's already written over here. And then For this one, the X group that direct the incoming Y group to the position of 2 and 4, 2 or 4. So in position of 2 or 4, it depending upon the nature, depending upon the first substituent. Okay, where can we get all this? This one is written in the data booklet. If we open the data booklet, this one, the data booklet, it is on this page written specific for the benzene. Not all of us remember, and we should not memorize what is the X group that makes the incoming group position 2 or 4. Which one? We should not memorize it. We can use the data booklet because it is the only thing that we can use. Okay, it is the only thing that we can use. So in this one, the X group that direct the incoming Y group to position of 2 or 4. The X is the NH2 amine. Amine. This one, not the amide, but this one is the nitrogen compound, NHR, and there is the secondary nitrogen compound. Okay, and then next for the OH or OR. OR, what is meant by OR? Can be an ether, OCH3, and then there is NHCOR. So when we add the substitution again of the other substituent, we have to refer to the structure. Okay, the nature of the X group. And then the next one, position 3. Position 3. Position 3, it is 1, 3, 5. If 3 can be 1, 3, 5. If 2, 4 can be 2, 4, 6. Okay, so in this one, what are the functional groups? So what we studied is not all of the functional groups of the benzene. It is only the partial, because we do not study all the structure of the functional groups of the benzene, or we call it as the derivative of benzene. Okay, so the nature, this one, this is important for us because we do not memorize all these functional groups because they are listed in the data booklet. We can refer to data booklet. Okay, next. Beside substitution, this benzene undergo addition reaction. It is the same reagent catalyst as alkenes. The reagent is hydrogen gas catalyst nickel. The difference is the condition. For benzene, the condition has to be harsh, strong condition, extreme condition. What is that? What is the extreme condition? 200 degrees Celsius, the same. The pressure, 30 atm. For the for the alkene, addition of alkene, it is not until 30 atm. 30 atm will be wasting of energy because until 2 atm it can react. So, but with benzene, it must use extreme 30 atm. Next, benzene can undergo free radical substitution, but not the benzene ring that undergo the free radical substitution. But it is the toluene, the CH3 or the alkyl of the benzene that can undergo free radical substitution. So in this one, benzene, first, if we use chlorine molecule, Friedel-Crafts catalyst, then become chlorobenzene. And there is possible for the chlorine to be attached here. But if the chlorine molecule react with the toluene in the presence of UV light or heat, then the chlorine will attack the methyl. It will not attack the benzene ring because there is no Friedel-Crafts catalyst. So undergo free radical substitution. These are the products. The main organic product is this one. And then oxidation. Benzene, the derivative of benzene can undergo oxidation. Again, the oxidation, it is not with the benzene, but with the derivative. What is the derivative of benzene? This methyl benzene. Methyl benzene reacts with this oxygen or oxidizing agent. What are the example of the oxidizing agent? It is acidified potassium dichromate or acidified potassium manganate. The condition, it has to be harsh condition, strong condition, which is reflux. How long the reflux is, we are not discussing in A level. We know that the condition has to be reflux. And the product is become benzoic acid. Let me ask Ariela. Ariela, have you ever read on any box, any container of food, the ingredients, there is a name benzoic acid?
Not really, teacher.
Not really. It is mostly in liquid food product, liquid beverages. If you observe, there is a benzoic acid. This benzoic acid, it is also used as a preservative. It is preservative, but it is safe preservative. Why? Because this is an organic. It can be digested by our body. Although it has overlap pi bonding system between the carbon and the pi bonding system. Okay, so if you found in any food products, example in the liquid form, jelly. In a jelly, there is in the ingredient list benzoic acid. It is the preservative, and how to make the benzoic acid? It is toluene undergo oxidation. Let me ask Kin to Nathan V.
Hello, cha.
Nathan V, have you ever come across with this word on the ingredient of food products?
Yes, it is in the form of vinegar.
Benzoic acid is not vinegar.
Ah,
It is
understand.
written. It is written on the food products on the package in the ingredient list. Benzoic acid. Not not on the nutrition facts, but on the ingredient list. So
Yes.
this benzoic acid is a preservative. It has wide range preservative uh, for the fungi. Fungi will die, will be dead using benzoic acid, and then for the yeast also will die because of benzoic acid. So mostly for making bread, we cannot use benzoic acid. Why? Because it has the wide range. Bread, we use benzoic acid, the yeast will not grow and will not become bread, but it will become unyeasted bread, bread without yeast. So this one can be used in the biscuits. Also, the second one, which the food, natural food, which is free from dangerous preservative, is tempeh, because tempeh is made up of soybean with presence of yeast. So if there is yeast is the very conventional living things, very old. It has lived more, uh, started more than us. The age is
Yes.
very long, and and tempeh cannot be preserved. Once it is preserved, although you put in refrigerator, the tempeh will become old, right? Similar to bread. Bread less likely to use preservative, although there is a preservative against against bacteria, but not against yeast. So this these are the safe food products. Next, next on Monday we will be discussing about phenols, because in the chapter is benzene and phenols. Phenols is the benzene with the OH, and there is a other substituent. Okay, so the benzene itself, the explanation is quite long. It is not short. It cannot be done within 2 sessions. If only giving the class on only explain without getting the understanding, yes, it can be done in 2 sessions. But in order to get understanding, it takes more time. Okay, so I'll see you again, all of you, on Monday.
Cha, thank you. See you on
Yes, see you on Monday.
Thank you, teacher.
Yes, you're welcome.